All right, so this is the August 2022 exam. So we're gonna go through this kind of quick. However, YouTube has a playback option uh, for the speed, so you can either slow me down or you can speed me up depending on your pace and how it is that you learn. So I'm just gonna go ahead and start out by just looking at this question and underlining certain key things that I feel are relevant. And it says, based on this result, hot and tasty coffee can infer that. And it says most of its customers in New York State. And I want you to remember that in this, it's talking about this specific location at the Staten Island Ferry Terminal. So that is too general. And for the second one, coffee drinkers care less about taste and more about being served quickly. They do care about how fast they are served. However, um, it doesn't say anything about taste, right? They obviously are going to want it to taste good. And so that doesn't really make sense. Number three, most of its customers at the Staten Island Ferry Terminal care most about being served quickly. That's exactly what this says. So that looks like that's going to be our answer. Most of its customers at transportation terminals and stations. Again, this is too general, so we can eliminate that. So answer choice three is the one that makes the most sense. Question number two. You could do this in the calculator by using the store button. So we could take 2.1, hit store, or any number besides 0, 1, or 2. And we're going to store that in for x. And then you can type in the actual expression, which is x minus 2i. To get the I, you hit second dot or second period. And then we're going to close this parentheses and square this and hit enter. So then what you could do once you have this answer is you could go ahead and plug in each of these answer choices, and then the one that matches most closely is number 4. Or you could do it the long way algebraically, which is by using the box method. So x minus 2i. And then when you do this and FOIL this out, you're going to get x squared minus 4xi plus 4i squared. We do need to remember, there's a little caveat, that I squared is the same thing as -1. So when we multiply -1 times +4, we're going to get -4, and everything else just comes down. X squared, and that is also answer choice number 4. Okay. For question number 3, it's asking you which one is the amplitude of the tide. So amplitude, this is our A. So our A is always the absolute value of whatever number comes first. So the absolute value of 4.8 is equal to 4.8. So that is the answer to this question. Okay, this is our A, this is our B. Pi over 6 is the number that's in front of the T. The C is our horizontal shift, and the D is our vertical shift. It's just asking us for the amplitude, which means height. This next question, the second word automatically says the word watching, so it sounds like it's going to be observational. Experimental, remember, is dividing it into 2 parts. We're not doing that. There's no experimental and control group. Sample surveys, when you're taking a survey of a smaller group, we're not doing that. Random assignment means that it's random, and it's not, it doesn't, we can't tell that from what it's given. So the one that makes the most sense given the context is observational. Question number 5. So for this question, I see that my answer choices are in degrees, so I'm going to go down to degrees, and I'm going to hit enter, and then I'm going to clear out of this. And the next thing I'm going to do is we need to remember that the first number is our x, second number is our y, first number is cos, second number is our sine. And so they're asking us to find this angle measurement. So we know that it has to be between 90 and 180. So we can definitely cross this out right now, right off the bat, off rip. This is a 90. Okay. So to find out what the actual number is, again, our mode is in degrees. So you could take either one of these and plug it in. So if I'm looking for the angle, I hit second. So let's just do cosine. Second cos. You could have done second sine and plugged in the 1/2 instead, but I'll just go ahead. Remember to plug in the negative sign and not the minus sign. Hit alpha y equals to get a fraction, option number 1. So this is going to be radical 3 over 2. You can close those parentheses and hit enter. and we get 150. So 150 is our answer choice. Okay, does that make sense? Yes, it's between 90 and 180. Which of these is true? So I want to remind you about what is a factor. A factor is where the remainder is equal to 0. So I would just go ahead and pick this one right here. X minus 3 is a factor. So set this equal to 0 and you get x is equal to 3. So what we want to do is we want to take our calculator, take 3, we want to store it in for x, hit enter, and we're going to plug in the actual function. So 2x to the third plus x squared minus 18x minus 9, hit enter, and boom, that's our answer. So if our remainder is 0, which it is, right? It's right there, then that means that x minus 3 is a factor. For this one, let's just say that that wasn't true. You take this, set it equal to 0, and you would have gotten x is equal to 1/2. And when you store that in, if it gives you a remainder of 0, then that would be the answer, but it's not. To test and see if the other ones make sense, I'm going to go here to the table. So it says f of 3. So what is f of 3? F of 3 is 0, right? We figured that out over here. We want to find negative 1/2. Since this goes up and down by 1, to get the negative 1/2 is you hit second and window or table set and type in negative 1/2, and then hit, you should have hit table, but let it do its thing. It's fine. It's fine. Um, so over here you hit go to the table, and now when you go to the table, watch what happens. All right, now it's starting at negative 1/2. So at negative 1/2, it's also 0. So does 0 equal 0? Yes, which means this is not true. And then it says f of 1/2 is 0, and if I go to 1/2, right, 1/2 is 0.5, I get negative 17.5, so that is also not true. So the only one that makes sense is choice 2. All right, this is straight calculator. Plug it in and see. So I'm going to go to my calculator. Let's go ahead and delete what's there. So I put the negative sign. Again, it's negative, not minus. To get log, you hit math, go down to log base, which is this right here. Type in 100. So typed in the rest of it, and then I'm going to hit graph. And basically I'm going to match, right? So it's not this one, definitely. It's not this one, definitely. So it could be either these two, not numbers 1 and 4, and I can tell that it looks closest to number 4. This part of the graph is missing, but it's in reality it is there. You would extend it up. So the answer choice is number 4. Okay. Which equation has roots of? The harder way to do it is plug each of these numbers into quadratic formula. That would take a very long time. Or roots means the zeros. So what you could do is you could take 3 plus I, you could store it. So 3 plus I, second dot, and we could store that in for x, hit enter, and then if you plug in each of these, so you would have x squared minus 6x plus 10, and if you were to hit enter, that's going to give you 0, okay? And then you would do the same thing for the other factor, which is 3 minus I. So 3 minus I, hit enter, go up and grab this, and if it gives you 0, then that first one is our answer choice. Boom. So it's this. Instead of doing quadratic formula over, another way to do this is, remember, like, if given the roots, that's the two numbers that go here. So you could take the 3 plus I and the 3 minus I, and you could FOIL this out. Let me make this a plus so it actually looks like a plus. You could FOIL this or box method this out and get 9 minus I squared. And remember, I squared is the same thing as negative 1. 9 minus negative 1 is the same thing as 10. That means that our C over A term, right? Our C term, this is our C. A is 1 in this case. Our C over A term is going to be, we have, this is 10, so this is going to be 10 divided by 1, which is equal to 10. And is our C term 10 here? Positive 10? Yes. This is negative 10, so it can't be that. This is positive 6. This is negative 6, so it's not any of those three. And again, if you don't understand that, like I said, you could do quadratic formula 4 times, get the same answer. All right, for the next one, as soon as you see increasing continuously or compounded continuously, this is on the non-negotiables, a PERT should come to mind. So A is the amount that you're going to have after all of this happens. P is the principal. It's the amount that you start with. E is a number. R is our rate. So this is 0.025 because you have to move the decimal place 2 places to the left. So that's our R. And then T is what we're looking for, but we know that it's going to increase to 15,000. So this is going to be our A. So we now just simply plug this in. 15,000 equals 12,000. E to the 0.025 T. You could plug this under Y1, plug this under Y2, see where they intersect. If you know how to use your window, ask me if you don't. If you want to learn how to do this algebraically, divide both sides by 12,000. So this cancels out. 15,000 divided by 12,000 is 1.25. So 1.25 is equal to e to the 0.025t. To get rid of e, the opposite of e is ln. So we're going to ln the left and we're going to ln the right. As soon as you see ln and e next to each other, you can cross them out because they're inverses of each other. So we have ln of 1.25 is equal to 0.025t. To get the t by itself, divide both sides. 0.025 cancels. And this is our answer choice. Answer choice number 4. Okay. Question number 10. So total number of points that are intersections. Okay, so y equals, this is something that we could plug into y equals. To get the y by itself here, divide both sides by x. So we get y is equal to 20 over x. So we're going to take both of these, plug it into the calculator. To get e, there are two places. Above the ln, there's an e to the, and above the division symbol, there's an e. So since I want e to the x, I'm going to do the one that's above the ln, e to the x, and then for the other one, I'm going to do 20 divided by x. So alpha y equals, option number 1, 20 over x. And again, please slow me down, and you should be doing this with me. Do not just watch me do this. It's creepy. That's creepy. All right, so what I'm looking for is the total points of intersection. Looks like there might only, yeah, looks like there might only be one. But I want to make sure, so I'm going to go ahead and hit zoom, and I'm going to do option number 0, which is zoom fit. Whenever it feels like doing it. Okay, so that's the first one. The y equals e to the x, and then the second one looks something like this. Okay, so I want to see what exactly is happening over here and to the bottom a little bit. So I'm going to go to the window and let me see if I can change my x max. Let's just make it 50. And then let me change my y min to negative 300, let's just say. See if that helps us better. So I can't see what's happening over here, but when I looked at the standard, right, when it was before zoom and option number 6 is standard, it was noticeably crossing at one point because this is an asymptote. There's a horizontal asymptote at the x-axis, and over here there's another, looks like another asymptote, except over here it crosses. So that is going to be 1 point of intersection. All right. Question number 11. So the first thing I did is I typed it into y equals, and instead of a t, I put an x, because we have a y and an x. And then the next thing I'm going to do is check out each of them and see if it's, which one is false. So the key thing here is which one is false, not true, which one is false. Like definitely underline that, because a lot of people will jump and be like, oh, look, I got my answer. So the first one says, in 20 days, there is no substance remaining. So I showed you how to do this, right? You hit second, instead of just going all the way down to 20, hit second window and start the table at 20, and then hit second graph, and you'll see across from 20, Yeah, we don't see the number 0 here. We see 0.49216. That's not 0. So A of 20 is about 0.49, so that is definitely false. That's our answer. But let's go ahead and just check the other ones. It says after 2 half-lives, there's 25% of the substance remaining. So what that means is 2 half-lives is 0.5 times 0.5. And as you can tell, 0.5 times 0.5 is 0.25, which is 25%. So that is actually true. This is true. For the next one, the amount of the substance remaining can also be modeled by, and you'll see if you take this and plug it into the calculator and type this and plug it into the calculator, they are not the same. I'm sorry, they are the same. And so that we can prove that this is true as well. Um, and then after 1 week, there is less than 10 grams of the substance remaining. So what we want to see is what is A of, after 1 week, there's 7 days. So after 7 days, there is, if you look at the table, that's about 9.9. And 9.9 is about 10, so that is also true. Okay, so we have 3 things that are true, 1 thing that's not, and it's asking us which is false. All right, I always show you how to do this next one using a drawing. So you're going to have an X and Y. So in looking at it, it has a vertex at 2.1. So they're going to give us the vertex. So 1, 2, 2, comma 1. So that's our vertex. And it has a focus of 2, comma negative 3. So here's 2, negative 1, negative 2, negative 3. So this is our focus. All right. So what is it asking us to find? They're asking us to find the equation, right? So the first thing that we notice is if our focus is here, then that means that our directrix has to be on the other side of the vertex, the same number of units, right? So we know that this is 1, 2, 3, 4. So this is 4 units away. So that means that our P is equal to 4. And then to find the directrix, you're going to have to go 4 up, right? So like, yeah, we don't have to actually draw it because they're not asking us for it. So we know that our vertex is going to be, our directrix is going to be somewhere up here, 4 up from here. So 1 plus 4 is 5. It's going to be right here, 5. And we can also tell that our vertex is, the parabola itself is going to be facing down because we cannot cross the directrix, right? It has to be going towards the focus, and the focus is down here. So our parabola is going to look something like this. So automatically we know it's going to be negative, so choice 1 does not make sense. All right, so now we're going to go ahead and let's plug it into our formula. So we are given the vertex, and the vertex is 2, comma 1. So we have our formula, y equals 1 over 4p x minus h squared plus k. So we're just going to plug stuff in. So y equals 1 over 4 times 4, because 4 is our p, right? We figured this out right here. And we have x minus our h, which is 2 squared, and then it's going to be plus k, so plus 1. And that matches, and remember, because it's facing down, our p is going to be negative, so this is going to be a negative sign right here. So negative 1 over 16, all of them have that. X minus 2, only these two have x minus 2. And this is plus 1, so our answer choice is 3. All right, so that is number 12. Number 13, you could store a number in for A, store a number in for B, plug this whole thing in, hit enter, and see which one matches. If you do that, the first one is going to match. But if you want to do this by hand, we have an A out in front, so I'm going to go ahead and put an A out here. These all are under a cube root, so let's go ahead and combine like terms. So 2 times 4 is 8. B squared times B is B to the third. And then this a squared is chilling by itself here, so we have an a squared. Okay, so now what can we do with this? I can tell right away the cube root of 8 is 2, because 2 times 2 times 2 is 8. So that means that a 2 comes out, and then this right here is accounted for, so that goes away. So I have a squared b to the third. And look right here, right? I have the cube root of b to the third. These two undo each other, right? If I wanted if I didn't know that, I can rewrite it as this is our exponent, so it's 3 over, this is our root, so it's 3 equals on the bottom. So b to the 3 divided by 3 is the same thing as b to the first, or b. So that means that I can take this right here and I can bring this out. So I have 2ab cube root of a squared. Since it's only a squared and not a to the third, this has to stay inside. So that is also choice 1. Okay, either way you do it. 2 ways to skin a cat. So for the next question, basically all you do is you take the function and you graph it. And so what you're going to see is you're going to look and see something that looks like this. Okay, so you're going to see somewhere over here that looks like there's going to be an asymptote. And it says as x approaches. So here's x, right? Here's x. So when x goes to the right, it's positive infinity. When x goes to the left, it's negative infinity. Okay, so it says as x approaches negative infinity, which means that as we go to the left, right, the question is asking us what happens to our y. The f of x is y. So what is happening to y, right? So y is approaching this number. So we want to find out what that number is. And you could tell by looking at the table that the number that it's approaching is 2. And let me show you that. So my calculator, when I graphed it, so I plugged it into my calculator exactly as it is in the question. And because I have put my table set to start at 20, what I want to do now is I want to go to negative infinity. So let's go to our table set. So second window, and let's do negative 20, right? And let's see what happens there. Oh, boom, 2, right? I just happened to see that. But if you didn't know that, you go to table set, go to 0, go to the table, and you'll see that the numbers as you go up is going to start getting closer and closer and closer to 2. Eventually it's going to hit 2. So that's what happens to y. It approaches the number positive 2. So the answer choice is 3. Okay. Next one. So as soon as you see is equivalent to, again, you could plug this into the calculator, store a number in for x, hit enter, match, and you'll see that the answer choice is 2. Or if you want to do it the longer way, on the top, this right here, to factor, I see an x goes into both. So x squared, right? X times x is x squared. X times 3 gives me 3x. So the top is factored, and I'm going to factor the bottom. I know it's a double bubble because it's not a difference of perfect squares, or I don't have to do it completing this, AC method or anything here. I'm looking for two numbers that add to give me 5 and multiply to give me 6. I can tell that's going to be 2 and 3. And what happens here, right? As soon as I see x plus 3 on top and bottom, they can get canceled out, and I'm left with x over x plus 2, which is also what we got by plugging it into the calculator. So for this question, this is very important to know, okay? It says a recursive. Recursive has something that has like a previous term or a next term or a current term. So if you look over here, the first one, this is not even recursive. Like they don't give you a number to start with. Like they don't give you your A1. They don't have anything that has AN minus 1 here. So this is not recursive. This also is also not recursive. This says 64 plus n minus 1 times 16. This is just telling us that it's an arithmetic. So automatically right off the bat, I already know it's not 1 or 3. So what is it? So let's check this one. A1 is 64. Okay, check, looks good. And then it says here, we're going to take the previous term, which is 64, and subtract 16. So is 64 minus 16 equal to 48? And the answer is yes. And if I keep doing that, right? So if I subtract, the pattern looks like I'm going to subtract 16 again. So do I get 36? No, right? I get 32. So it works for these two, but it does not work for this, which means that this is not correct. So by default, it has to be this. So let's go ahead and prove that. So the first term is 64. And then this rule says the pattern is keep multiplying by 0.75. Keep multiplying by 0.75. So let's see if that works, right? I have 64. I multiply by 0.75. And I get 48. Boom. I take 48 and I multiply it by 0.75 and I hit enter. I should get 36, and I do. So 4 is correct. Again, I have the word is equivalent to. So store a number here plug in, see which one matches, and 2 is going to be the one that matches with it exactly. If you did not know that, right, you could sit there and you could divide. So let's go ahead and do this real quick. So we have x cubed, and then we have a minus 2. So we do not have an x squared term, so we have to add that. We do not have an x term, so we have to add that. But we do have a minus 2 here. Okay. And we're dividing that by x minus 2. All right, so very quickly, let's go ahead and do this. X goes into x cubed. How many times? And that answer is x squared. So we're going to multiply. So that's going to give us x cubed here. Switch the sign. X cubed times 2 is going to give us negative 2x cubed. We have to switch that sign. So that's going to be a plus. So this cancels out. And I'm left with 2x cubed. No, sorry, this is squared. 2x squared. 2x squared. Bring down the plus 0x. So x goes into 2x squared. This is going to be plus 2x. And then I'm going to multiply again. So this is going to be negative 2x squared. I'm going to write into the next problem just for now. 2x times negative 2 is negative 4x. Switch that sign. So that's going to be plus 4x. So this cancels out. And I'm left with 4x minus 2 over here. X goes into 4x. 4x plus 4 times. 4 times x is 4x, switch the sign, so that's negative. 4 times negative 2 is negative 8, and switch the sign, so that's positive 8. And I have a remainder of 6. So I have x squared plus 2x plus 4, check, plus 6 over, and this goes on the bottom, x minus 2. So answer choice number 2. What's the solution set? As soon as I see this question, I could also, right, split this, put this into y1, put this into y2, and see where they meet. And I will see that the only place that they meet is negative 1. Okay. Otherwise, you could go ahead and do this the longer way, right? So if this is part 2 question, let me just go ahead and give us some more room right here. So we have to get a common denominator. So x squared, well, k squared. So if I factor this out, I get k. I should get the same thing, minus 6 and k minus 2. Okay, so over here, I just factored this right here. Over here, I have a k minus 2, but what am I missing? I'm missing a k minus 6, so whatever I do at the bottom, I multiply it to the top. And over here, I have a k minus 6, and I have to multiply it by k minus 2. Whatever I do to the bottom, I multiply it to the top as well. So now that the denominators are the same, I can pull out my red marker and I can cancel the whole thing out. So it's not a waste because I still need the top. So I have k times k is k squared. This is a minus 6, so that's going to be minus 6k. And then over here I have a plus 1 times k is k, and 1 times negative 2 is negative 2. So I'm going to go ahead and combine some like terms. So I have k squared. I'm going to have minus 5k minus 2 equals 4. Let's bring everything to one side. So I'm going to get k squared minus 5k minus 6 equals 0. And then this is factorable. So k minus 6 and k plus 1 is equal to 0. So I'm going to split this in half. And I have k is going to equal 6, right? Switch that sign. And k is equal to negative 1. Also switch that sign. The last thing we have to do is take it and plug it back into the original. And I can see right away that as soon as I plug in k equals 6 here, 6 minus 6 equals 0, can never have that, ever, ever, ever. So that is an extraneous root. That is wrong. So the only answer is negative 1, which is what we got by plugging into y1 and y2. All right. Question number 19. So this is an identity problem. And again, you could go ahead and it says which equation must also be true for all values of x and y. So you could store numbers in for x and y and see which one is true, and then keep like switching it up. The other thing that you could do, and so if you do that, you're going to get choice number 1. The other thing you could do is you can kind of go ahead and you could work backwards. Like you could take this and like FOIL this out. So let's go ahead and do that. So x squared times x to the 4th is x to the 6th. X squared times negative x squared, so that's going to be negative x to the 4th y squared. And then when I do my last one, I'm going to get x squared y to the 4th. And then I have plus, so now I'm going to do the same thing here, right? So I have plus y squared, so this is going to be negative x squared y to the 4th, and then this last one's going to be plus y to the 6th. And we should be able to see that some things might cancel out. So let's see. Oh, this should have been, I missed something here. This should have been a plus sign, right? This should have been a minus sign. No, that should have been plus. Okay. So I have x squared, yeah, which works out. Because look, x squared y to the 4th, negative x squared y to the 4th. They cancel out. And over here, I got sloppy, so I wrote that y squared. I didn't write x to the 4th. And if I did that, that is the same thing as this, right? Y squared, see y squared, y squared? That's the same and x to the 4th. X to the 4th. So one of them is positive, the other one's negative, so that also cancels out. So what am I left with? I am left with x to the 6th, right? I'm left with x to the 6th, and I'm left with y to the 6th, which answer choice number 1 works out, okay? The other ones will not. The next one. So for this question, you're going to go ahead and graph this. This is very important for us to do together. I see that my answers over here have pi instead of degrees, so I'm going to change my mode to radian. When I reset my calculator, it does that automatically. So second plus 712, just in case you forgot. And then I'm going to go right here to my calculator, my handy dandy, go to y equals, and I'm going to go ahead and type my function in. So I have 3. Move this over. I have 3. I have sine, okay, 1/2. So alpha y equals option number 1. So 1/2. And then instead of theta, I could just go ahead and put x right here. And then I'm going to close those. So now I want to see what happens on this interval from negative pi to pi. That's my x. That's my theta, right? So let's just make this simple. Let's go here to my x to my theta. And let's change it from negative pi. So negative and pi is here. Second and this caret key, the power. And then over here, I'm going to change this to pi. So second and the caret again. And it's fine to go by 1, negative 10 to 10. Okay, so now let's go ahead and graph it, and let's see what happens. So it says, given this on the interval from negative pi to pi, what is the function doing, right? So I can tell that the function starts over here, and again, we always go from left to right. It looks like the function is steadily increasing, like it just keeps going up. It doesn't dip, it doesn't go down, right? It's steadily increasing through this interval. So that is correct. It doesn't decrease and increase, you know, none of the other ones make sense. So that's just plugging it into the calculator. All right, we're almost done with part 1. Done with part 1, that rhymes. Which expression determines the total? So keyword here is total amount of money. And there is a formula that we have for that, right? That's in the formula booklet. A1 minus A1 R to the N over 1 minus R. We could also write it with a summation. So let's go ahead and see which one works, okay? So A1, our first term, is 59,000. So let's go ahead and write that down. Minus 59,000 again. And then R, we're going to look to see what number does this go up by. So to do that, Delta Math and I taught you a shortcut. You take the second term, 64,900, divided by the first term, 59,000. And when you do that, you're going to get 1.1. So our R is going to be 1.1. And we're going to raise it to the N. and it says over 5 years, so n equals 5 here. So I'm going to put it to the 5th power, and it's going to be 1 minus, and then our r again is 1.1, so 1 minus 1.1. Does that, is that there exactly? Yeah, actually it is right here, right? So that means that 1 is our answer choice. Let's just say if it wasn't, right? Then you would go ahead and see if this would work. So n equals 1. Remember what this means, right? Here's our n. Here's our total, right? So what this means is you're going to take the 1 and plug it in here. So 59,000 times 1.1 to the first. And then that's going to be 59,000. And then you would plug in the number 2. So 1.1 to the second power times 59,000. So that's going to go here. And then you would keep doing that 3, 4, 5. And then the last thing would be to add all those numbers up and find the total. That's what the summation does. The calculator also does it for you. So to get that, you hit math and you go down to summation right there. And then this is where you would put in your, instead of n, I just always put x, 1, go up here to 5, and then put the function in, hit enter, and that'll give you the summation. But since we already know that this is the one that matches when we did geometric series, that's correct. That's done. All right, 22. All right, so for this question, we have a train has arrived on time 64 out of 80. So 64 out of 80 days, it's arrived on time. And we want to see, we want to raise that to 90%. So 90% is 90 out of 100. So let's just think about this like logically, right? So we have on the first day, it's on time 64 out of 80. And then it says which equation can be used to find x, which is the number of consecutive days, right? So like on the next day, that's the 65th day, it's going to go up by 1, right? So this 80 is going to go up by 1 because it's now another day. So that's going to be 81. And then for the following day, it's going to be 66 out of 82. And we're going to keep doing that until we get to the 90 out of 100 day, right? Which is the 90%. So let's kind of look at what did we do to get to this next number, right? We took the top and we added 1, right? And to the bottom, we also added 1, right? So in this case, our 1 is our x, right? Because it says x is the number of consecutive days. So over here, x is 1. To get from here to here, now x is going to equal 2, right? Because 64 plus 2 is 66. So x equals 2. And whatever we do to the top, we also have to do to the bottom. So x equals 2 here. So we're adding 2 in this case, right? And we're going to keep going. So it looks like our formula is going to be, we take 64 plus x, right? Depending on the day that we're talking about. And whatever you do on the top of adding the x, you also add the x to the bottom. And then you keep doing that until you get to 90 out of 100. And which answer choice matches that? Answer choice 2. All right, so we're done with that. Question number 23. And that's a one-off. Doesn't always happen. Which statement is true of the inverse function, f of negative 1 of x? So we do need to know what negative our inverse is. Inverse means that you take, this is our y, right? And this is negative 2 over 5x plus 4. Inverse means that we're going to take our x's and y's and we're going to switch it. So x equals negative 2 over 5y plus 4. And then we're going to see what exactly happens with that to see which of the answer choices make sense. So let's go ahead and get this y by itself. So we're going to go ahead and subtract 4 from both sides to get this y. So x minus 4 is equal to negative 2 over 5y. And then to get this by itself here, the y, we can multiply both sides by 5 to cancel this fraction out. So whatever we do to the right, we do to the left. So multiply that by 5. So this cancels out that 5 and this 5. So we have equals negative 2y and 5 parentheses x minus 4. And then to get rid of that negative 2, divide both sides by negative 2, divide both sides by negative 2. So we're going to have y equals, because I always like putting the y first, we have negative 5 over 2 and x minus 4. which if I were to distribute this, I get the same thing as y equals negative 5 over 2x plus 10. Okay, so what does this mean? This means that the first number, right, the number that's in front of the x is my m, which is my slope, and this number right here is my b, which is my y-intercept. Okay, all right, so let's go ahead and see what that says. So it says inverse is a line with a slope 5/2. That's not true. So let's cross that out. Inverse is a line with the slope 2/5. That's also not true. So if I look over here, it says the y-intercept is at 0, -4. This is a little bit harder to rule out. I would have to like plug this in. But 0, -4, that's not true, right? Because our y-intercept is at 10. So this is also not true. So the only one that makes sense is 3. And if you were to take y equals -5 over 2x plus 10 and put that into your calculator and put the number 6 here, so -5 over 2 times 6 plus 10, you would get, sorry, if you would plug in the, yeah, you would get -5 as your answer. And so you could go ahead and check that to make sure. All right, so that does make sense. For this last one, an equivalent form, again, y1, plug this under y1, and then each of these under y2, and see which one is equivalent. In this case, since all of them have A0, and we don't, it says A0 represents the initial substance, we could just say A0 is equal to 1 in this sense, because we don't know. And then plug each of this in. So what you're plugging into the calculator is y equals, right? Again, this is an imaginary 1. So we have 0.5 to the t or x over 0.0803, and then you plug each of these in. So you plug in y equals, for this one, 1 times anything is itself, so you would have 0.000178 to the t or to the x, and see if they're equivalent. And as soon as you plug in the first one, you will see that they are equivalent. They're the same graph. All right, that is part 1. Phew, 42 minutes. We got this.